We should also know the ray diagram for convex and concave lenses. So when a ray passes through a convex and a concave, at certain point it will converge. And what are those? How they converge? How they converge? At what point they converge? So about this we should know. So let's study about it under this heading. So this is the ray diagram for convex and concave lens. So let's write the first one. Let's take a convex lens. So this is a convex lens. This is the principal axis. I'll also take concave lens also. I'll also take concave lens. Now, the first ray diagram for convex and the concave lens is like this. If the ray is parallel to the principal axis, there is a ray which is coming from this direction, from one side of this convex and a concave lens, and that should be parallel to the principal axis. If the ray is passing parallel to the principal axis, then what happens is, then after refraction, the ray will passes through the second focal point. See, I think I have told you about this while discussing some of the terms which we use in this one. So focus, two focuses are there, focal points are there. So this is for this surface and this F1 is for this surface. So F1 and F2 are there. Similarly, we have two central curvatures. So that is why these are called as a foci, which is a plural form of focus. So two foci are there. So when a ray of light is incident parallel to the principal axis, then the refracted ray will pass through the second focal point. And what about for this one? So if the ray of incidence is parallel to the principal axis, and after refraction it will move like this. If you extend the path of this, at this point it has been refracted, it has changed its direction. If you extend it from that point in a backward direction, that will appears like originated from this one. So if you look at this, if you look from this direction, it appears like it is originated from the focus. So this will happen when a ray is in parallel to the principal axis. So in other words, what we can say is this ray is appear to diverge. This is a converged one. From this point, a ray appears to be diverging. So this is what happens when the ray is moved parallel to this principal axis. Now let's write the first point. First point is, if ray is incident parallel to principal axis, then refracted ray passes through second focal point, appear to diverge. This is for convex lens, this is for concave lens. Appear to diverge from first appear to diverge from first focal point. So this is the first case. Now let us see the second case. Second case is, again we have to draw convex and the concave lenses. If the ray is passing through the if the ray is passing through the optic center, so if the ray is passing through this center of both the convex and the concave lenses, then the ray will go without any deviation. The direction, there is no change in direction of the ray when the ray passes through the optic center of the lens. So this will be in the convex lens. Similar effect will be observed in the concave lens also. So here also the ray goes undeviated. It doesn't change any direction when it passes through the optic center. So this is another kind of a ray diagram for both convex and concave lens. If ray is incident at optic center, then refracted ray undeviated. Refracted ray undeviated, doesn't change its direction. So this is the 2 points, 2 kinds of ray diagrams. Let's see the third one. Third one is, if the ray is passing through the first focal point, if the ray is passing through the first focal point, if the ray is incident through this, if the ray is passing through the first focal point, in the case of convex lens, then the refracted ray will move in parallel to the principal axis. The refracted ray will move parallel to the principal axis. This will happen when a ray is passed through this first focal point. If a ray is passed through this concave like this, and this will appear to meet at second focal point, which is F2, this is F1, which is appear to meet at the second focal point, and they have at this point it will undergo refraction, and the refracted ray will passes parallel to the principal axis. So this is in the case of concave lens. So this is the direction of incident ray which appear to meet at the second focal point, and after refraction they will pass parallel to the principal axis. So let's write the third point. If ray incident at first focal point or appear to meet at second focal point, appear to meet at the second focal point, then refracted ray passes parallel to principal axis. So these are the 3 ray diagrams for concave and the convex lens.
Let us also see some image formations in the case of convex lens. Let's look at the first figure. In the first figure, the rays are coming from infinity. In that case, image is forming at second focal point. So the object is placed at infinity, image is forming at the focus. Let's come to the second one. In the second one, the object is beyond 2f. 2f means it is known as the center of curvature. So if object is placed beyond the 2f, beyond the center of curvature, then you can see image formed between f and 2f. You can see in the second picture. Let us go to third one. In this case, object is kept at 2f, means object is kept at center of curvature. You can see the object AB and you can see the image A dash B dash, which is also falling at 2f. So if object is placed at 2f, image will also form at 2f. Let's go to the fourth case. In that case, object AB is placed between f and 2f. In that case, image is obtained beyond 2f. See, object is in between f and 2f, image is forming at beyond the 2f. Let's go to the fifth case. In the fifth case, if the object is placed at f at the focus, image, see, we cannot see a converged point. That's why we can say that image will form at infinity. And the last case is if the object is within the focus, see, less than f, within the focus, then you will get the image on the same side as the object. So that's why this is the virtual and erected image. And for all other 5 cases, we are getting real and inverted images. So this is about ray formations in the case of convex lens. You can see table also. This is the position of object and position of image for the convex lens. Also, you might have observed that for a concave lens, if you kept object at any distance from the lens, it will always form virtual and erected image. So this is about image formations in the case of concave lens.